So in today's lessons, we're going to be doing three different types of vectors, vector problems. One, we're going to be doing an angle between two vectors, i.e. a relative angle, and then another one we'll do a quadrant bearing type vector, and then another one is an absolute bearing. Now, first question. Rob and Doug are working together to pull a wagon. Rob applies a 60 Newton force, while Doug applies a 50 Newton force to the wagon. So we're going to draw a free body diagram just like you would see in physics. This represents my wagon, and then this vector here represents the arrow that's pulled by Doug, and it's 50 newtons. And then this angle here is going to be the vector that's being pulled by Rob, and that is going to be 60 newtons. Now it says that this problem has Doug and Rob having an angle of approximately 40 degrees between them. So in order to create an additive vector between these two, we have to take this vector here and we have to copy it and parallel and just put it at the end of this vector. So we're going to do that right now. Now, in doing so, you get something that looks like this, which is essentially Doug. Now, what we have to do is we have to extend this line. By extending this line, we know that this line and this line are parallel. So that means this angle here is 40 degrees, which means that this angle is 140. Because 140 and 40 gives 180, which is a straight line, which is what this line represents. Now, we're going to have to create our R value. So our R value is the resultant, and it starts here, and it goes all the way here. So let's do that right now. It's going to be in blue. Now that I have my vector, we're going to call this R, just like I said earlier. So let's do the calculations for R. In this case, R squared is going to equal 60 squared plus 50 squared minus 2 times 60 times 50 cosine of 140. And we have the magnitude of R, when we take the square root of it all, is 103.4 newtons. Now, the next thing that we have to do is we have to calculate X. X is going to be the angle that is relative to Rob's pulling vector. So we're actually looking for this angle right here, from here to here, and that is X. So now we'll compute that. So we have sine of X over 50 is equal to sine of 140 divided by 103.4. So I got sine of x is equal to sine of 140 over 103.4, which approximately is this answer. So sine of x is that. When we do the inverse of this angle, x is 18 degrees. Now, for the final statement, you're going to say, therefore, the wagon is pulled at 18 degrees off Rob's vector with a force of 103.4 newtons. And we're done. And now let's move on to question number 2. For this problem, we have an airplane that heads northwest with an airspeed of 500 newtons. Now, always start by drawing your bearings since it's quadrant bearings. And now we're going to draw our quadrant for the airspeed of the airplane. So it says the airplane is heading northwest at 500 kilometers an hour. So this is northwest. Now the angle here is 45 degrees. The angle here is 45 degrees because it's northwest. So now let's continue. The next problem that we have is the airspeed. Now, because the wind is coming from the north, we have to do this. So we'll make our direction finder, and the air is coming from this direction, and it's coming from north, sweeping to the right 65 degrees. So let's have an approximate graph of what that looks like. So this is the direction where the air is flowing. And then essentially, this angle here is 65 degrees. Which means if I was drawing the direction vector from this angle here, it would essentially be south 120 kilometers an hour south 65 degrees west. So that comes from the Z pattern that's formed right here. So parallel, parallel, and then boom, follow this. That means this angle here is 65 degrees, which means if we start from the south, and sweep this way, it's 65 degrees. Now, to make the red and blue arrows additive, I add them tail to tip, tail to tip. So I've copied this vector down to here. Now I notice if this angle is 65, I know that this angle here is also 65 using opposite angles. Now if I know that this angle here is 45 degrees, that means this angle here is 45 degrees as well. Now I'm going to just make sure I copy down the lengths of this vector. So this is 120 kilometers an hour, and we're going south 65 degrees west. So now, in order to calculate our final thing, we have to actually figure out where our start and end is. In this case, our start is here and our end is here for our final vector. So now we're just going to draw that really quickly. And that is our resultant vector. Now, let us calculate R using cosine law. Now you'll notice that the angle that I came up with was 110. The reason why that was is because we added these two vectors, these two angles, which in essence turns out to be theta is equal to 110 degrees. After doing all of this, we calculate the magnitude of R to be the following. Now, R is 552.7 kilometers an hour. That is its magnitude. So now let's calculate the angle that we need for this green value here. So we need the angle from here to here to find the actual quadrant bearing, because we need the angle that sweeps all the way across here. So that's why we need to go and compute x. So we'll start by doing sine law for x. You work through sine law and you'll eventually get x is equal to 12 degrees. And we're going to say, therefore, relative to the ground, the plane is just flying 552.7 kilometers an hour, north, 57 west. So when we deal with true bearings, this is our starting position from the north, and we sweep around. So from here to here is 0 to 90, here to here is 90 to 180, here to here is 180 to 270, and here to here is 180 to 360. So let's begin our problem. So now we'll start with our hash, and then it says that this graph, this first one travels 50 knots at a bearing of 70 degrees. So it looks like this. The next thing that we always have to do is we have to tell where the 70 degrees is. So it sweeps from here to here is 70 degrees. Now, what we have to do next is we have to create our next hash. So for our next hash or direction, we'll use, it says it's 120. I'm going to draw that in blue. It's 12 knots with a bearing of 120. And that's what the boat is doing. The boat is pushing in that direction. So it's very similar to what we did before, but essentially we end up with a vector that looks like this, where this angle here, from here all the way around, is 120 degrees. So in order to find the angle between them, I have to use, in order to find the angle between here and here, we have to do some funky math. Now, you know, using Z pattern, that this portion here, this angle here has to be 70 degrees. Now, using the fact that 180 degrees is a straight line here, if this portion is 120, that means this portion here is, you guessed it, 60 degrees. Therefore, our theta is equal to 70 plus 60, which is equal to 130 degrees. Now, what we're going to do is we're going to draw our resultant vector. Our resultant vector goes from here all the way to here. Now, just like before, we're always going to use cosine. We're also going to call this r. Make things simple. So we'll start with r squared. And we end up with this for r, 24.5 knots. The next thing we have to do is we have to compute the complete bearing from here to here. I'm going to call this angle here x, because that's what we're looking for. So now let's do that. And we get this result for sine of x. Just take a moment and copy that down. And this is our final statement. The resultant direction is 24.5 knots with a bearing of 92 degrees, because we had to add 22 plus 70, which is right here, in order to find our actual bearing. Now, please remember that this is the last portion of the unit. We now have to start thinking about doing the applications, and then you can start your review for your test. The notes are up. You have a review period on Monday, and then test will be Tuesday.